Hello, everybody. Good morning. Share my screen. Yes, so thanks, Andy, for the introduction. So today we're talking about doing the right thing, shifting left. I'm Jayesh Bapu, as Andy introduced. I'm founding member, product management at TraceableAI. I'm also the AWS machine learning hero and do some AI research on the sidelines. If you want to connect with me on Twitter, you can find me at Jayesh_. So today we will be discussing about three things at a very high level. What is shifting left? Why should you shift left? And how can you shift left? What, why, and how, these are the three fundamental questions I feel everybody should ask while doing anything in their life. So that is why I put together these three questions. And during the session, we'll try to address these three questions at a very high level. So let's just go through the recap and see how the current state of the world looks like. So APIs are eating the world, and literally every single application which is being built today is running the microservice architecture, has a bunch of APIs. Some of the customers we have been working with, we have even seen more than 5,000, 10,000 APIs at the scale. And why this is happening? So we're living in an API first economy where every organization is building API first applications. Building the API first application gives you flexibility to upgrade things, upgrade the functionality very easily, and release functionality independently, manage things very easily. It provides a lot of flexibility in a way. And with the help of CI/CD, containers, cloud native architectures, DevOps practices which are evolving over the period, the speed of software development life cycles has increased over the period as well. And that's where this continuously changing, continuously evolving API first economy is resulting into a rapid development cycles and rapid release of the new APIs and functionality. And on the other side, we are living in a very dangerous world. The sophisticated attacks are being democratized. Most of the information which this pen testers or hackers needed to know or learn over the period is now available very easily on the internet. You can even ask ChatGPT how to hack through things and you might get the 5 results out of it. It is that easy at this point. So a bunch of crypt kiddies sitting somewhere from a basement, hacking large banks and trying to exploit money out of it. The sophisticated attacks are democratized. The information is accessible to more and more people. And how to use the information depends on their concerns. The security teams and SOCs are overloaded with different responsibilities over the period, and APIs are emerging as emerging attack vectors as per the different reports. Then when we go to some of the statistics over the period, like only 20% of the organizations following the DevOps practices consistently integrate security into the development process. And seen it at a bunch of places, security is mostly afterthought, and having it as a part of your development process is not something which everybody thinks as the primary concern. So that's where the number is pretty less. It has to go the period, but even right now it's pretty less for that matter. And then only 15% of the organizations can remediate the security vulnerabilities or address the compliance violations as soon as they arise. And this is very critical because some of these are P0, P1 vulnerabilities, which are impacting customers, and your readiness to resolve these vulnerabilities, solve for these issues as soon as possible is very important. Then when you go through a normal stats, right, a defect that is removed after the product has gone into production will cost you around 100 times more than the one that is identified and removed during the requirement phase. And as I said, security is afterthought, and that's where you don't, in most of the cases, in the very early stage, you miss out on the consideration of a security during the requirements phase. And that's where if things go into production, if things go into customer environments, the impact of these things is way more. The cost to resolve that is way more, and it just doesn't cost in money, but it also costs in reputation. And that's where having the whole thing integrated into development life cycle or security being the first thought in the process helps a lot. So these are just some of the codes, but how we then how should we think about the API security, or how should we think about the security life cycle for that matter? So there are three phases of a development as we briefly talk about it. There's a development phase, there's a pre-production deployments which happen, and then there's a production deployment. During the development phase, shifting left, closing the loop in CI, finding vulnerabilities, mitigating them. In pre-production, actively testing for vulnerabilities during staging, prioritizing the security issues on a bunch of different parameters, which we'll discuss in the latter phase, and fixing them. And then during the production, having the runtime API security and discovery in the place, and doubling down on it over the period. All of this comprehensively provides you a distributed API security mechanism for complex distributed applications, and it works throughout the life cycle. So what is really this? We're talking about shifting security left, but what really is the shifting security left? So shifting security left means moving your security practices left into the software development life cycle, with the goal of shifting from a reactive to more proactive security posture. And when I say reactive, this is very normal in most of the organizations, where security issues or vulnerabilities will come into picture later in the life cycle. And that is the point when we try to mitigate it, when we try to solve for them. But shift left security allows you to have a more proactive posture in the nature, and finding these vulnerabilities in the early stage, mitigating them as soon as possible, will help you be in a better state when it goes to production. Then is it this simple though? Like, is it this simple that I just move the security from right to left, right? It's really not. There are a lot of nuances into it, and why most of the organizations don't prioritize it. The traditional security practices which we are going through are very manual and time consuming. So when we look at current security pipelines, what generally happens is you write a code, you commit the code, the pull request happen, now the security team comes in, tests that particular release, and raises bunch of pen testing team comes in, tests that particular release, and there's bunch of vulnerabilities that are represented in that particular release. And at that time, this information is now passed on to development team. They are going to fix it. Once they fix it, the new release comes in. Again, these people test it and again go back. So this cycle continues until security team feels like everything is fixed and we can give it a go now. So this is very manual and time-consuming cycles, which might sometimes cost a couple of weeks. Then developers and security have a very different domain expertise, and that's where the major challenge comes in. Most of the courses which we teach in the computer science from day zero don't talk about security as a first-class thing. And that's where when people get into development, people start coding, don't think about security in their mind. For them, the delivery of a feature, the faster delivery of a feature matters more than a general writing a secure code for, as a first thing. And that's where this the expertise security team possesses and the expertise development teams have are very different. And for them to communicate these things to each other becomes challenging as well. And that's why security tooling doesn't really surface information in a developer-friendly fashion. When you show developers some bunch of vulnerabilities with some CVSS scores and CWEs and CVs mapped to them and the OWASP mappings and everything, that's not the information they can really associate with. For them, it's an issue. For them, it's a bug. You have to provide this information in a developer-friendly fashion for them to understand the nuances, for them to understand the priority, for them to understand why we should fix it. And that's when the things will become little simpler over the period. But all of these issues really make this thing a little tricky to do that. So what's the right way to shift left? So I need to say right way to shift left, but there are few ways you can really do that. The first thing is having a security first design. Security should never be afterthought. When we start thinking about building a feature or a product, we should consider security even during the requirements phase. And even that solves most of the problems which exist in the current life cycles. Even having a basic security training for your developers and making sure they understand the nuances, they understand the good practices is good enough to start with. Then the second point is automation is the key. You can't really be on top of things in the modern world because the things are evolving so fast for humans to catch up, for human testers and uh, the loop to catch up and have that information out there takes time. So having a right set of automation via CI/CD pipelines, which test for particular test cases and gives you the list of vulnerabilities, prioritize list of vulnerabilities which should be fixed, helps a lot. Then third point is control gates are always your friends. So having the right set of guardrails to protect your code base, to protect your uh, functionality, to protect your product from bad actors is very important. And that's where the control gates in a case of number of vulnerabilities, the number of critical vulnerabilities, or OWASP API top 10, PCI DSS, all putting the control gates on these different parameters, these different compliance standards, and making sure that none of the vulnerabilities under this should go into the production, go into the release that is going into production, really goes a long way. Then the fourth is correlation. This information, like there are a bunch of tools which we use day to day. There's a SAS scanning which happens in most of the companies, happens maybe via Sneak, maybe via SonarQube, maybe via Veracode, check marks. We use a bunch of these tools to do the SAS scanning. Then there's a dash scanning, which might happen via Zap, StackHog, and other tools. Then there's a IR scanning, which happens via Traceable, some other tools. And then there are real-time protection tools which come into picture. All of these different tools are giving you a bunch of vulnerabilities, bunch of issues, security issues, misconfigurations, which they find in your system. Having a correlation across all of this information and providing a prioritized list to developers is very important. Then using developer learnings to better protect the production. So developer is the one who knows most about the code base and the hacks they did to do that, the nuances around why they wrote that particular thing, how they wrote that particular thing. Mostly developers know about those things. So using this developer learnings, using the understanding of a developer of a code base to better protect the production code base, really goes a long way in the whole cycle as well. So doing this few of the things right will really help you shift left. So how do we close loop? How do we really augment all of these things and make sure that what are the actionables around it? How can we say on top of the things, right? So first is updated visibility into your APIs. Should have the detailed API specs for most of your APIs. The documentation part should be sorted. Then the API changes and ownership should be maintained properly. If there are any functionality changes, if there are any parameter changes, those should be documented. And the ownership of all of these APIs should be properly documented. Then there's the API DNA and baselining of different parameters, different request response parameters which are there in the API. Then second is using production learnings to perform the pre-production testing. Sometimes with testings in pre-production, it's working well. You don't find any issues. You push it to production and suddenly some attack happens. You're trying to, you might be able to mitigate it. You might be able to avoid the whole thing, the fiasco, but at the end, you should not just leave it as an attack which you were able to avoid. Using the learnings from production environments, the attacks which happen in production, the attacks which are even attempted in production, to create a test cases for pre-production, and using those test cases there for increasing the test coverage, more realistic use cases for testing, helps to get you the right sense of things. And establishing the right API risk model, identifying this API risk in pre-production environment, establishing a very positive security model which can be leveraged across the production and pre-production environments helps a lot as well. Then the fourth thing is identifying vulnerabilities before they even get into production. So capturing the context of the problem, communicating it to developers with the common tools, the tools which they understand, the language in which they understand it, and prioritize based on the risk, prioritize based on if this can be exploited into production or not, really helps. And having all of these four things looped into your CI/CD as a part of your CI/CD pipelines and running continuously will definitely get you to a way better security posture. So during these 3 steps of building, shipping, and running the software, what are the different tools which can come handy? List down more when I share the slides. This was just quick thing. So for the vulnerability, first thing which comes is the build phase, shift phase, and run phase. Whatever the vulnerabilities you find, how do we manage and prioritize it better? That's so the tools like Traceable, StackRox need come into picture, help you manage these vulnerabilities better, prioritize them better via correlation. For compliance, you have tools like OPA. For access control, you have Fortify and other tools. For cloud native security, you have Traceable, Aqua. For runtime security, you have Traceable, Contrast security, and a bunch of other tools which really help you in this different phases of software development lifecycle. So that's mostly it from my end. I think it was pretty short talk for the time. But yeah, if you have any questions around it, please feel free to reach out to me and Jayesh at traceable.ai or ping me on Twitter at Jayesh_1. And if there are any questions on the Slack, I will be happy to take them. Thank you. Do the right thing. Shift left.